Let's turn our attention now to the level beach house, which has a slightly different detail and something that's a little more complicated. So let's switch over to some views, which actually show, there's Schindler. Let me try this one. That's a pretty good example of what's going on in the level beach house. Take a look at how that detail differs from the Schindler house, or the King's Road house. In this case, what's happening, we again have a joist system. We have kind of these joists running at, in this case, it looks like 2x8s or 2x6s running at about 24 inches on center. But you'll see that Schindler's doing something very interesting here at the roof level. At the floor level, 2x8s are running pretty much at 24 inches on center. 2x8s again looking like they're around 24 inches on center. That looks fine. There'll be a thin plate of the floor, just the planking of the floor. And it's hard for me to tell from this section whether it's open at the bottom or whether there's some sort of sheetrock or plaster, something that closes the bottom of that space, or whether it's all open exposed beams. But up at the roof level, there's something even a little more interesting going on where we have these 2x6s, then 2x8s. The roof planking is actually sloping. And what ends up happening is he has to go through and fill in the gap, okay, which is really, it's going to turn out to be sort of an incredibly painful detail. Something where I don't think this detail got repeated a whole lot, because as we continue to move through all the Schindler buildings, you'll see he doesn't use this system that often. We have the 2x8s, and there's about a 3/4 inch piece in there. Then there's 2x8. As we get bigger, the pieces get bigger, then it gets to be a 2x10, and there's a bigger piece of filler. That's just sort of a really hard to construct detail, as well as just kind of detail on it all out. So let's go ahead and show you how you model that, but then we can think about why we actually moved away from this sort of system. So if we want to go through and take a look at something like that, let's go back to our Revit model. I'm going to switch back over to my sample wall systems. And let's pop on out to a different part of the model. You'll see I still have the King's Road model over there, but if I pan myself over, you'll see that where some of the other wall types are set up, I have just a kind of standard system of some joists set up, and these are all just sitting on top of those little like 2x like partial walls that are happening at the soffit level. So in this case, I just have a bunch of different little structural elements. If I have them all arrayed together right now to kind of make the spacing easier, but you'll see they're all 2x8s. Okay, so the top of them are basically at, it's really 2'8" above the soffit wall because the bottom was at 2 feet above. So let's just go ahead and close it up, and we'll think about how we can extend these. The idea is what we're going to do is go through and put a roof on top of this, then fill in the gap between the roof and the top of these joists. And to do that, again, I can look at it a number of different ways. Let me go up to level 2 and look down and see if I can see them. Maybe in level 2, to see these, I will go ahead and turn up the fineness. There I can actually start to see the joist now. And we'll put a roof on top of this and give it a slight bit of slope, and then we'll think about filling in the gap. So the idea is as follows. We can again go through and put in a footprint roof. I'm not going to worry too much about the boundaries this time, because we can go ahead and be finer about that for the purpose of what we're showing right here. The big thing is I just got to put a roof on top of that. And then relative to what we want to do, what I want to do is turn off the slope on most of the different edges. Say no slope there. And then on this side, I'm going to give it just a sort of a very subtle slope, like 2 in 12, 1 in 12. Something that's really just enough to get the water to drain. Okay, maybe even just 1 in 12. I don't think it actually was very steep. Okay. In terms of the height of this roof, again, it can be the 1x8 planks. That's still appropriate with the tar and gravel on the top. It's not going to be at level 2. Really, this was going to be at sort of soffit, starting about 2'8" above, and then sloping from there. Okay, let's give that a try and see what this looks like. So a little hard to see what's going on in that direction. Maybe if I cut a section in the other direction, we'll get a good sense of what's happening. Just a moment as it saves. Okay, we cut a section. Let's take a look. a little steeper than I was hoping for. Let's go ahead and change that down even further. Maybe it's only about a half an inch, something like that. See if that'll work. Quarter inch? We just really don't want to have too much slope on there. Okay, that's probably a little closer to what we had in mind. So here's the deal. Let me bump those up to a bigger scale and maybe even turn on thin lines so we can see things a little bit better. There we go. So here's the issue. We have this little gap between the tops, okay, and the roof plane above, and that's what we need to go through and fill in. Now, putting those all in as individual structure elements is really kind of a difficult thing to do. So let me kind of suggest sort of a workaround that may be a better way to model this that really sort of have the same effect. One of the really nice features about walls is walls have the ability to go through and attach themselves to the roof above. So rather than going through and putting these in as individual structural elements or even modeling them all individually, a nice trick or a workaround we could use is to actually sort of model these little pieces as wall elements and attach them to the roof. So let me show you what I mean. If I come back into the level 1 floor plan again, and I go through and place in some wall elements. Now these walls are really beams, but we'll go ahead and make it work in terms of what we want to have happen. It's basically that 2-inch wood, which is going to be sort of what we used as the kind of softening for the wall all around. The base constraint here is going to be, it's going to be the soffit plus, oh, what is it, 2'8". And I know that. That's just really the level of the top of these beams right now. It's complaining to me a little bit right now because, oh, what's happening here? I say 4 feet there just to make them extra tall. That's how they need to be. Oh, they have to sort of actually be physically possible. At this, I had a kind of a series of top and bottom constraints that wasn't going to be possible. So given this, what I can now start doing is going through and placing these walls which are acting as beams. In terms of doing this, oh, we could try to do it by center lines. Let me try picking, we'll say that we're going to use the wall center line, see if that'll work. Can I get the center of the beams? If not, I'll just do the edges. That looks like that's going to be good. Oops, looks like I missed a little. Let's try that again. I'll pick it there. I'll pick it based on the wall center line. Try putting one of those in there. It says it's not visible, it's kind of above our head. That should be okay. Let me try putting a few more of these in. Okay, and let's take a look at it in that section view, see how we're doing. Looks like we actually have them all running low right now. Well, let's fix that. Oh, where does it want to be? I want to be soffit plus 2'8", going up unconnected. Okay, there they all are all sitting on top right now. Of course, that one over there looks like it's a little off in terms of the left-right centering. To fix that, what I can again do is, I'll say that I want to modify, and I will align and maybe just get, I can get, since it's in a group, it's going to give me a little bit, or it's arrayed right now, it's giving me a little bit of trouble in terms of doing the alignment. Right there. Okay, that'll be good. I could even lock those into place. Here's basically the deal. I have all these different wall elements. I have this roof element. Let me even shade that so you can sort of see what's going on here. If I want to go through and just sort of have things that automatically adjust to the appropriate height, what I can do is take these individual pieces and say attach the top to that. Again, I'm going to attach the top of that little wall element to this. Again, I'm going to attach that little wall element to this. And attach that. But you get the idea. Just attach them there. Again, this isn't exactly, I guess it is an accurate way to model it. It feels a little bit strange using walls to sort of go through and create those fill-in pieces, but it actually is an effective way of going through and having something that's going to automatically resize and adjust. The nice thing about it doing it this way is, if, for example, that did change to half, Okay, you can see they all resize themselves automatically, which go ahead and fill in that gap nicely. So if Schindler had this ability to go through and like put it in place to do his like drafting or to actually fabricate these in the field, he probably would have appreciated this ability to kind of fill in the gap between the top of the joists and the bottom of the sloping roof. Okay, so that's really the essence of what's special about the level beach house roof. It's just these variable height joists. Once you go ahead and put in these filler pieces and attach them to the roof, you're in pretty good shape. You still have to go through and put some parapet pits or some fascias on the edges of the roof, but that'll get you pretty close to where you need to be for that style roof. And you can sort of see them. There they are. There's my little fillers sitting on top, and they actually sort of render themselves pretty nicely even in the 3D views. Those will look good from the bottom if we go ahead and take a look at those from a perspective view too.